Let's hope so. Let's hope so.
Dozens of DC insiders who have attacked marijuana, in some cases for years, are now plowing a fortune into a backdoor legal cannabis investment. They put millions of dollars into one backdoor investment, setting themselves up to make a fortune. Now, if you follow Judge Jeanine, one thing you know for certain is she speaks her mind. And she's tackled some of the biggest, most polarizing issues of our day. Now, she's going to expose one of her most interesting and profitable stories to date.
Okay, hopefully. I don't know about Ken's invention for cannabis. Am I looping? Sound okay? All right there, sleeper. Now don't be fucking with me. That was a pretty bad looping. Okay, all right. Sounds good so far. Hang on. Okay. Now is it getting worse? I have so many different sound projects on this server now, and some of them were running in the background. I had two different stream splitters. The echoey part may be the building, but also may be building that loop, so let me know. That loop was pretty freaky. Yeah, the problem is I need to use this microphone here in order to be able to turn around, looping again. All right. Okay, hang on. Oh, echo but not looping. The way it's set up, yeah, I grant you that. It's a self-built server, so I got crud all over it. Let me disconnect a few things and see if that helps. On the video, then that would be the feed in. The speakers are off. Speakers are totally unplugged. That's what I'll do. Hang on. Okay, let's see. Headset earphone. Hello? Sound now? Okay. I only have a small cord. I'm going to have to get an extension. Sorry about that, guys. There's just, as I was saying, there's just so much crud on this machine that I was running into all of these other processes. And I need to take the time to strip it all off and eliminate a lot of the stuff. Actually, a lot of the stuff I've loaded in the last couple of days. But eliminate some of the things that were used for... Now it's looping? Echo still? Echo now? echo. All right. Okay. Okay, so no sound. Okay, one more time. No echo, but do we have sound? One more time. Test, test, test. Not bad. Okay, let me crank it up a little bit and adjust the gain. Echo, looping. Annoying as crap. All good? I have people saying still echo, but let's go. You say reverb? Okay, so that would be echoing. Another source. Okay, I can try going straight webcam. We'll see what happens there. Yeah. I know about that. That should be straightforward there. It's the simplest I can make it. Okay. All right. Damn it. Sorry. Okay. I have a bunch of other issues with it. I had to disconnect a whole array of stuff I've got going, and I'll have to reset it. It was this stuff that I had running on I thought, in a safe space or partition here. Okay, so let's get to it. Let me shift the things around here for me so that I don't get too confused, because it's going to be a bit involved here. All right, so no, I don't do Morse code. I've got enough problems. I don't like memorization, okay? Memorizing formula, fine, but I would rather write a software that did it for me. And it's very simple to do that anyway. Okay, so what we have here is a representation, poorly drawn, not to scale, only partially labeled, of figure 1 of Boscovich. But I drew this because I didn't want to write on top of this up here. And we will get around to discussing sound. Let me do my little abstract here. We're going to discuss sound as a control system for the experiments that we're going to be running. We're going to be discussing sound and the theremin, this weird instrument. We're going to be discussing C60, radiation, Antarctica, woo-woo shit, sinkholes, and UFOs, and control systems for UFOs. Okay, so anyway, so what we're actually looking at here, according to Boscovich, and I'm not going to waste your time or get too in-depth in it, but I wanted to point out why Boscovich and the Tic Tac UFO mesh, okay? Because Boscovich is talking, this is a representation that he produced in a book that was first published in 1758, I believe, and then republished in 1763. marvelous illustrations, marvelous graphics all the way through it. I print them all out because I'm reading the thing online, and you have to reference this a lot, right? And so you got to come back to it. And he made three-dimensional. The guy anticipated computers. He bitched about all of the arithmetic he had to do to make his little geometry work here, but he was quite enthralled with the fact that he didn't have to go much beyond basically quadratic equations, and even those were extremely simple and few and far between. He was dealing with very simple kind of equations to manipulate the ether, reality, the dielectric, magnetism, and electricity, although he didn't really call it electricity at the time in the 1763 volume. He refers to it as motive or motive force. So anyway, though, so what I wanted to point out was that his it's very sophisticated graphics, and if you look at them in just a little bit of a way, you'll see exactly why I think that all of the mathematics stuff that he's got here for magnetism exactly describes what we saw with the Tic Tac UFO. So I'm reading along in Boscovich's book here. I'd gotten through part 1. He writes this in a strict logical fashion. Each paragraph is numbered. You can stop and contemplate the 4 or 5 sentences in each paragraph as he goes along. He tells you explicitly it's not going to get any more complicated than this kind of geometry, and that you're not going to get involved in the complex formulae that some of the other guys drop off into. And then he step by step by step by step gives you logical principles to think about, and you can say, yeah, I agree, you're 100% correct on that one. Let's go to the next one, which builds upon the previous one, and you'll build your way through part 1, where he discusses the nature of the reality that we find ourselves in, and you can see that he's exactly describing reality perfectly. Then he goes on to start describing where reality comes from, how it manifests, the actual mechanisms of manifestation. And he does this through a description of the dielectric plane, and he does this through a description of magnetism. And he describes it in language within constraints that we are dealing with now, but it's nonetheless very readable, because here's what happened. In the 1700s, he had to write it all in Latin, because that was the common language in Western Europe. As far as he knew, the rational intellectual world for expressing ideas. And the fact that he put it in Latin gives us some really interesting things, because Latin is very precise in terms of its exact definitions for all of this kind of stuff. And then a guy translated this in 1921, and the guy who translated it did so with references that I actually learned with, because, Latin text translation shit didn't change much between 1921 and the 50s when I picked it up. So I was dealing with materials that were written in early 1900s. The guy in 1921, he was dealing with materials in the early 1900s in terms of how you translate, various different aspects of Latin and so on. And it's really straightforward. It's one of these, very straightforward kind of structured languages. It's not as obtuse nor as irregular as English or Sanskrit. So it's easier to express very straightforward factual ideas in the logos and logic in Latin, but you can't get quite as fanciful as you could with English or Sanskrit, etc. So anyway, so that aside, we find ourselves dealing with a guy who did a translation in 1921 that's really damn good. There's some small improvements we might make, but nonetheless, it meets our needs of the moment, which is to build UFOs, or basically little floaty RVs, and go truck about all around the planet and go fishing and, spend our money in various places, having good lunches and so on. So although we have to note, all this coronavirus stuff says to us we probably shouldn't go to Mars until we figured out how to deal with viruses and shit. Even here in Earth, it's dangerous to go walk about in areas where your biochemistry is not adapted to the local biome, and you might get some aspect of it, or you need to understand that your biome is not as robust as it should be, and you need to get it all plumped up so that you can handle shit like that. So all of that aside, here's what actually happened, okay? I'm reading along in this. I go through part 1. I hit part 2, where he discusses what he calls the application of his theory to physics and or mechanics. Now, mechanics at the time in the 1700s included what we would think of as engineering, motion, machinery, measurement in the form of like surveyors, engineering measurements, flow measurements in rivers, all of that kind of stuff. Anything that had to do with anything that could be derived from motion or from an extension of motion through space, such as surveying or measuring with a tape or something. All of that was mechanics. Everything else was philosophy, because it was just thinking about it. So he wrote a philosophy in which he came up with a theory, and then he spent the last half of the book, the majority of the book, the really cool part of the book, in applying that theory to mechanics or the real world. And now he spends the first half of the book telling you how he derived his theory and why it is sound. And then he starts describing that theory in its application to mechanics, physics as we go forward here. And he has to do this with these various different figures that he has created, such that we can follow along on the simple maths that are involved. And it's arithmetic. It's real simple arithmetic too, because he wasn't dealing with UFOs or trying to do all of this stuff, you know, balancing way the hell up a couple of 100 feet in space and all of that sort of thing. So getting back to all of that, so the application of, I'm reading along in it, I hit part 2, and I had been following the Tic Tac UFO, and one thing that was really intriguing about that UFO is something you just don't see in any other the UFO videos, because we don't have that many that are that tightly focused on the actual UFO, right? From a plane of viewing where it is more or less level with it, it's in the same environment. Usually we're looking up at these things obliquely from a denser atmosphere through a lighter atmosphere where all kinds of clouds and stuff can intrude. So we don't get a really good picture. So the Tic Tac UFO stuff was really was revealing in so many different ways. And it gave me such a great insight into how they must operate. And then I come along and I see these charts, that Boscovich has prepared, read his text all the way up from, in part 2 in the articles, up to about 233, and you see that he's describing everything that is the motion of these UFOs through space as a result of the dielectric plane and magnetism. So what I'm going to do now is to remove these, because I need them. You know, I don't want to print them out again. And we're going to discuss actually what I saw, right? Because I'll bring this one back later. It's got other bits on the backside that we might not be able to get to. But anyway, so here we are with his description of magnetism. And we can imagine that back here is the magnetic source for what we're looking at, okay? And what we're actually looking at is a spiral that spirals around in 3 dimensions. And it goes around this dielectric plane. So we're looking at one of these, like one of these little spiky deals in here, okay? And so this representation behind me is a 2-dimensional description of the arcs involved in the cone of the central spike that's being held there by these 2 magnets in this ferrofluid. All right? Crap. Anyway, so it's one of those spikes that we're looking at here. A couple of things to note. This spike up here tells us that what I'm about to tell you is true. But Boscovich derives this truth long before you get to really start looking at these charts and stuff. But one of the things that is absolutely true is that not all magnetic fields wrap back around inside the magnets. Magnetism does not work that way. Magnetic fields, as we see them expressed in reality, that idea comes from a particulate approach to viewing magnets based on iron filings, which presents us with an entirely erroneous view of what magnetism is and those areas of it that we really care about. So 2 things to note about this. In his description here, he clearly shows that there's these asymptote lines. They don't ever return back. They're infinite. They may, you know, go and fade out and peter out into nothing, but they make no effort to come back into the rest of the magnet. And they exist in 2 aspects of these little spiky deals, okay? One of them is that as it comes out of the magnet, there is a It's as though the magnet has broken the dielectric and a force is emitted that would appear to be conical, would appear to be spring-like in many respects, and has an asymptote there and one here that is infinite. So these lines will never, ever, ever come back to the dielectric plane or its perpendicular. They come down and they go like this, okay? And so he's describing this, and then he describes a few more things in, you know, the next, say, 30 articles in the first part of part 2. And I get the idea, oh my God, here's what he's talking about. These are limit points in magnetism. If we look at them in relation to the vertical, the perpendicular AB here, which is off the dielectric plane, these are the limit points where it turns and comes back, okay? And then it goes through the dielectric plane. And so what we can do is we can say right now that artificially, just arbitrarily, we're going to decide that the top half of this graph area here represents what we can call felt perceived repulsion. That's the force that you can't push the two magnets together. And then on the other half of the dielectric plane down here, we'll call this attraction. Obviously the force that jams them together. Okay, so just for our own thinking, all right, and we're not going to get muddied up in the definitions. The repulsive force here can be compressed up to a certain point, and that compression may be infinite from a universal viewpoint, but it is very finite from our ability to actually achieve that compression here in the materium with sufficiently strong enough magnets. With weak magnets, you can, of course, touch the opposing poles, and you'll feel it a little bit in resistance, but you can easily do that. But you'll go over a certain threshold, and then you really have to start working, and the pounds per square inch in order to get it there become very difficult to deal with, and at some point you cannot make that occur, no matter how much physical force you put in on that magnet. And what's actually happening in a conceptual level is that this spring is being pushed back. Okay, so at a conceptual level, the spike is trying to be compressed downward, and it doesn't want to go downward. And some of the reasons that it doesn't now, bear in mind that spike is not really described by a single one of these, but by an infinite number of these that are all ever so slightly behind or ahead of one of another, all going out into this cone, many of which become asymptote and go off infinitely. Those that do not get captured by the process, and that leads us to our perception that the magnetic lines come and re-enter into the source of the magnet. Doesn't quite work that way. There's some conceptual nuances there that we need not get into, but Boscovich covers it all, okay? So, all right, so anyway, it gets a little bit interesting from here. So we're dealing with repulsion force. Our goal is to deal with our tic-tac UFO, which will be this little blue magnet critter here, okay? And so from our viewpoint, let's say that our tic-tac UFO is sitting right here. And that's actually I'll have to do this in a different way. That's actually the guy sitting inside our tic-tac UFO, whoever the hell was inside controlling it. And there's the tic-tac UFO itself sitting out in space. Now, for a minute, let's forget about our limit points of magnetism, where it turns, and let's just consider that how is this guy sitting up there in space, according to my thinking here? Well, what he's actually doing, because I'm reading along in Boscovich, this dawns on me as to how this all occurs, because Boscovich describes some really interesting things. And so I'll get to those interesting things about limit points and so on in just a second. But what's actually going on here is that this guy has the ability to isolate himself magnetically from the magnetism that is around all the other magnetic fields that are around. Now, in doing so, this means that it becomes becomes impervious to magnetism. So that is to say that if we were to conceive of gravity as they have all different kinds of names for it and shit, but let's not get bogged down in the weeds. Let's just call gravity a cousin of magnetism. And we can think of the Earth as like magnetically trying to pull things down to it. It doesn't work that way, but conceptually it helps us here. Well, what he is doing, because he's isolated, is that he's compressing repulsion waves underneath it such that by the time, we'll assume this is the ground, that by the time he gets down to the ground, they're really seriously packed in there and are resisting any more movement of that UFO towards the ground. Okay, and it's doing this kind of thing with a control system that it has internal to its operation. And so because it can isolate itself from the local magnetic field, it becomes impervious or opaque to magnetism. And then it can, because of its ability to control it, it actually just simply compresses these magnetic waves down here, and it's nice and comfortable, and it sits there and sort of floats, and it can probably dial how far down in these layers it wants to go because of some features of magnetism. Some interesting things about magnetic field lines. When you actually touch them with anything, pushing two magnets together or whatever, when you actually touch magnetic lines, they disappear and you go on to the next one down. They collapse ahead of you, so to speak. So as you do attraction magnetic lines, as you collapse one, you instantly jump to the next one because that's the next line ahead of you, drawing you in this attraction part, which is why the UFO can move so fast, because it sets itself at this point on a repulsion, and it's magnetically isolated. It turns that magnetic isolation to a different orientation, as we noted that what was so peculiar about that was that it turned its orientation. The Air Force guys or Navy guys are all whipped up. The pilots say, hey, look, it's moving its belly around and shit, right? They're puzzled by this because they always fly in a swooping kind of an orientation. What this guy does, though, is it sort of rests on this, then it takes its isolation, and it creates another repulsive lines here that start compressing against these repulsive lines, giving it a motive force going that way, and then it reduces or opens its magnetic attraction on this way, and it jumps to that next point, to that next magnetic attraction point. But here's the thing about that, guys. Those magnetic points are not fixed relative to each other. If you are magnetically isolated from the magnetic field of the Earth, so to speak, or the magnetic fields that are around you, and you have the ability to dial your relationship in with these magnetic lines, you can make this area right here expand out as far as you want, but you're still jumping from one magnetic limit point to the next. So here he's at H, getting ready to push off against H to become attracted to M, and then before he does that, he just takes M and kicks it out 500 miles. Boom! It takes the same amount of time, and Boscovich goes into this, how time is related. Don't get bogged down into that, he's 100% correct. But it takes the same amount of time for a UFO guy to go from H to M, if that's 100 miles or 1,000 miles. Truly, it makes absolutely no difference. There's no friction involved, doesn't slow him down any. All he is doing is jumping from one to the other. This is how the Navy guy got all whipped up and said, oh my God, he's all of a sudden, they just looked and he was over there. He was over 60 miles away or whatever it was, right? Some big number of miles. And it traveled it just like that. What he did was to reset his destination point to approximately where he wants to go, and then he jumps to it. And how do I know that it's approximate? Because the mathematics involved are approximate, because we're dealing with an approximation of the ratio of the distance and the inverse of the distance squared, right? And that's an approximation in reality. It's never precise. And lots of people wondered why that's never been precise. Feynman got a little bit bent out of shape about it frequently, but especially because it altered all of his very deep math. But that's an aside. Okay, so it's imprecise here. And another thing that tells us that Boscovich is correct on this is that in 1763, when he published this book, he predicted that if one could move in this fashion, you would encounter, when you went to your destination, an oscillation that you couldn't control. or that you couldn't eliminate. It would always occur. And the depth of that oscillation would occur based on the amount of deviation between these 2 points in magnetic turning radius. Okay, so it relates to turning on the dielectric plane, not physical distance in the reality, but the amount of force in the turn going into the next part of the dielectric there. So here was a guy in 1763 that said, okay, you're hopping in your UFO. You hit go. When you get to go, the UFO is going to vibrate back and forth, potentially quite violently, with this oscillation. What do we see in Commander Fravers' gunship thing? We see that incredible oscillation. And then it turns itself, and it goes poof. Now, presumably, when it got to the end of that poof, there was another oscillation. But anyway, so that right there was the first clue that Boscovich knew what the hell he was talking about, right? So anyway, so all right, so let me, so now we get to the idea, we get the concept that these things can isolate themselves from magnetism. All about us is magnetism, if you want to think about it a particular way. Magnetism comes from the dielectric plane, from the ether. These are what might be thought of in a loose form pressure waves, a standing pressure wave. The standing pressure wave component of it means that you can alter your relationship to its internals and do little hops and skips, which I really screwed up with all the sound. I need to get moving, so we won't go into some of these details I wanted to cover today. Do them another time. But basically, the concept is the unique way in which they travel means they can't fall out of the sky. They can drop really rapidly, but because they're magnetically isolated, they're isolated from gravity. So you're still sitting in there, no zero G's. And when you get down to the point where you're about ready to collapse and smash into the planet, all you've done ahead of that is to set your magnetic field so it's repulsive to the Earth's field and set some limit as to these compression layers, and then you stop and you just hover on them. Again, oscillation, but you're inside that, but you're in a magnetically shielded bubble, and off you go. So there you are. You're not going to be hassled by it. Okay, so now, all right. Now, then one understands, since basically all you're going to do in order to move in this system, you don't warp reality, you don't warp space-time, there's no need to even think about it that way. The energies involved are not required. What you do is select your particular magnetic wave frequency that you want to ride, and then you manipulate it to give you the ride that you wish at that point. So it's going to take you as much time to go from H to M if they're very, 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 very close together as if they're several hundred miles apart. So you're going to find that moving short distance is going to be real slow, okay? Because you got to keep them real close. You got to keep these distances real close so that you don't hugely overshoot. And so these are going to be weird little kind of craft. They're going to be reasonably safe. I suspect because of the nature of being magnetically isolated, that when they become magnetically isolated, there's a sort of a alternating repulsive and attraction field that ends up around them, so you're shielded from radiation. And you'd also be shielded from bumping into stuff because of this effect of building up those magnetic waves. Because the magnetic waves would be coming on out as they would impact stuff, the etheric blowback from matter would be such that it would compress, and there you go, it would save your ass and you wouldn't go smashing into it. Anyway, I found this quite fascinating. It's led to all different kinds of the Boscovich stuff, all the different sorts of intriguing ideas. There's all different kinds of thinking that can produce potentially what we might think of as free or it's capital intensive, but not maintenance intensive energy. And so let me put this back here. All right, so our guys here on the Tic Tac UFO are manipulating our energy points here. And they could, if they wanted to, go whoosh, all the way through again and come down and deal with the attraction waves. There we go. All right. Okay, so now also something about these spacecraft. Look how cool they are, all right? Once we get our breakthrough, and our breakthrough simply will involve some kind of a material that will do things to magnetism that we don't yet know how to do. But, and I can define all of those, I can go into it, but I'm not going to do it at the moment because I have buggered up the sound issues. Anyway, but look how cool this is. No need to carry fuel, right? Whatever it is going to be drawing this from the dielectric. You're not going to be packing around gasoline, or you might have a propane canister to cook from. But that'd be about it, right? So anyway, so there's that. Be very small. It can be as small as you want, because you don't have to have vast quantities of rocket fuel to go blasting around. You don't need rocket engines. You need something that'll sit there and it'll probably go and hum along and produce all these magnetic waves. Now, the bad part so far is that these magnets are not anything you can be around. The ones I've got here have disturbed my sleep. They're so powerful. So I've got to keep them isolated. They were initially contributing to part of the problems in this. And I'll get into that in a second. So we got to be careful with the magnetism. So we as humans have to have a situation where, as a human, we are inside our little craft, but we have to be isolated from the effects of it magnetically so that they're all headed out, and so that we don't scramble ourselves just by getting in and hitting the go button. And this presents some interesting things of thinking, because I'm running into those same issues with my experiments. Okay, so I'm gonna take this off for a second, but hang on, I wanted to go back to this. This is Boscovich's description of this travel method and how you could preset these things and do your jumps through space. This is an adaptation of figure 1, and it's adjoining to figure 12. And what he does throughout this, in all of his figures, by the way, is that he builds on figure 1. And he will relate each and every one of his sets of figures on these advanced ones. This is figure 33 that shows you how to control things through a three-dimensional reality with magnetism. And we can even build it into a heads-up display and place ourselves into the moving parallelograms and rhombus and decide where we are. It's real simple algorithmically. But anyway, he builds up three-dimensional pictures with these continuing stream of graphics. So you got fun pictures, guys. It's a little tedious reading sometimes, but you got some fun pictures to work with. But anyway, so here he was in 1763, anticipating that we would need a control structure for these craft and how they move. And here's some of the math, by the way. Here's how you could make that work. Now, he doesn't explicitly say that. He doesn't reference that. You have to just have that in your head, that I'm going to build this craft, and then you look at what he tells you, and you see that he's describing all of this. And the only thing that's keeping us from making this now is that we don't have a central key component that allows me to build an isolating, non-fatal magnetic bubble around myself, right? So they've got all kinds of magnetic bubbles, but they kill people, like the tokamaks and the fusion bubbles, all of those. You can't be around them. They scramble your brains. They muck with your DNA. So it's all, a big pain in the ass. This is why I'm all back in on C60 again, okay? I found that I can deal with the magnets a lot better, and my sleep's less impacted. First off, I boosted all of my pineal gland through peptides, through endolutin. Took that for 10 days, felt really good, everything's fine there. And then I've been up on the C60, and so far the magnets have had far less effect on me. So anyway, so now we're going to remove all of this and go on to the next phase of this, where I wanted to discuss some of the issues with what I'm doing in the magnets and the problems in making that breakthrough, okay? Because I'm only one breakthrough away, and I need a material. I need to discover this material, and I will be able to start working my way towards this isolation effect. And then I know from the way in which innovation works that once I've had that singular breakthrough, it would be like Edison finally discovering how to make the filament in the light bulb, and then everything flows really, really rapidly, because while he's been stymied, things have built up around it on the other aspects there. Okay, now Edison was an asshole. He was abusive. He was non-empathetic, pain in the butt to deal with. He ripped off Tesla and all different other kinds of people. And as you can tell, I'm not a big fan of him. But he did find a light bulb. So anyway, All right, so here's the issue. What I need to do is I need to find a method for interacting with a standing magnet, a permanent magnet, that, yeah, Edison was a dick, yeah. Okay, so I need to find a way to deal with a standing magnet, and then I will be able to propagate results from that to an electromagnet where I will be able to dial in power and adjust ranges and stuff. But I don't want to be dialing in and messing with power yet until I've got my fundamentals correct in terms of how I'm dealing with the magnetic lines, the little spiky things, right? Because it's my goal to do things with other materials that will directly affect the spiky things within the magnetic force lines. These other materials will not be active. That is to say, I'm not trying to shape any of this kind of stuff with an active electromagnetic field exerting a pressure on the outside of these magnetic lines. That is not my approach. Okay, I'm not going to get into why I want to do these things or exactly how I'm going to, or exactly what the goal is. An astute individual or an inventor should be able to infer from what I'm describing where my goal is, and the race is on, guys, because I intend to patent this. Anyway, so here's the thing. In order to do this work, in order to examine these kind of interactions with magnets and other material, you have to do things like eliminate those things that are going to intrude on your experiments. So we can't, for instance, presume that we're going to use anything that is magnetically sensitive, you know, any iron-based material that's going to be magnetically interacting and altered by the magnetic field. That's not what I'm after. I'm after something that will cause changes or react to that magnetic field without the alteration of it at this stage, for a number of different reasons, okay, for sensors, basically. So my idea is that before we can get to that isolation stage, we've got to be able to accurately read magnetic fields in a way that we cannot now. And so some of these efforts that I'm doing now are towards that end, towards making a sensor arrangement of to basically build a different kind of relationship with magnetic sensors. I've got EMP meters, I've got all different kinds of angstrom level radio frequency sensors, I've got H-wave measurers, but they're all electromagnetic. And so in the process of this, they would all fail because they're not going to interact well when I'm pumping out vast kinds of magnetism, and they won't be accurately reading and telling me what I need to know about that magnetism. So that's my first goal, is to build this sensor array so that I can figure out at a very subtle level where things are going on within magnetic interaction between me and the magnets. And I'm quite certain it'll be at what we now call a molecular level. That is, precession of the molecules. The way in which the molecules themselves line up in our material reality will be part of this process. Very difficult thing to do as a you know, a wacky loon internet inventor kind of thing, because you usually need huge labs, or the approach to it in an academic fashion is huge labs, sometimes involving gas chambers with ionized gases or radioactive gases and all that sort of thing. And I don't have the time or the patience for that. So what I'm after is a system that I can use in an interactive fashion to be able to do an Edison-like hunt for materials, to be able to acquire materials, put them into my quick test, and then throw them out if they don't produce the effect I'm after, and to go on to the next set of materials. And I'm hoping by reading ahead in Boscovich, because he does have some hints as to how particular materials will interact, scattered throughout, that I can get a jump on which materials to buy in order to winnow down the potential of going through 10,000 materials to find the 3 that I'm after, right? So we've had some early success. This is a borate-based crystal, and I looked at some of the stuff in Boscovich and determined that at a far-end sensor, that borate-based material would be a far better sensor than anything based on iron. In a crude experiment that we did, we found that borate reacted 37 times further away from the magnet than did iron. But our approach on this is not to quantify through mathematics how far away. It is to find specific reactions. The borate is within a category of stuff to pursue further, but it's going to require machining for me to get at that to make those productions. And I'm not at a level yet where I can make an accurate sensor, but on my way. Okay, so here's what we're going, all right? So what I did was I bought a musical instrument as a magnetic sensor. This is a Theremin. You can look it up. It's a, yeah, I know about Ken. I've sent him some emails. He's never responded back to me, so piss on him. Theremin here is a musical instrument that is based on radio frequency field being reasonably stationary and held between two antennae, one for pitch and one for volume. And it builds a magnetic field around itself. Let's build in a little box here to control those two antennas. And that's basically the musical instrument. And you stand there and you do all of these weird kind of hand manipulations, or, you know, wave your dick around as far as I know. I don't have it yet, right? And I'm not going to be waving my dick around, especially not around magnets or electricity. But anyway, in essence, you disturb the field, right? And it makes noises for you. They're monophonic. They have a complete octave, but very narrow range of what you can get out of them, although there's lots and lots of depth, right? So my thinking, and it has been validated, okay, so but it gets really complicated. My thinking was that I could fine tune this field so that it would react when I started mucking about with magnets and materials in there. And that if I found the right material, I should be able to get a discernible, audible notification via the field of the theremin. It's sound reasoning. There's no reason to suspect that it won't work, but it's a lot more complicated than you think. Because I'm not going to be able to stand there and manipulate these materials, because my presence alone as a conductive being and making movements is going to create all kinds of audible shit. So I have to come up with mechanisms for manipulating stuff inside the field those mechanisms have to be done through non-conductive material that doesn't interact with the field. So I'm in contact with some plastic manufacturers to get samples to try various different kinds of push rods and stuff to activate, you know, this kind of a deal, right? But also, I need to be able to have actuators and activators that won't themselves interact with the field, or if they do interact with the field, will be at such a small level that I'll be able to screen them out. Okay, so this is how all this shit gets really complex and why it's expensive to invent shit. Now the Theremin you can get for reasonably cheap. I found a $99 Theremin Shield for Arduino. I'm not using that because I don't have the time to solder it all up myself, but they're reasonably cheap to get a quality you know, noise producer here, right? And it's only music if someone knows how to use it and makes it musical. For me, it's noise. It's an actuator. It's an indicator. It's a giant form of a very sophisticated beeper. But once I've got my magnet in there, and let's just say that this is my little magnet, and then I have my little chunk of material, and I'm going to have them interact. And what I'm trying to do is to sense the alteration of what we think of as the magnetic field coming out of here, but we know are really actually all the spiky shit. And so I want to get this finely tuned such that deviation, which is that's all the Theremin is about, is deviation within the field equals production of some form of a noise. And then in order to get at this, though, now I start getting into some interesting things, because I got to go modular synth. I've looked at the synthesizers and so on, because if I'm using little actuators and stuff electrically, even, you know, compressed air, that sort of thing, they will interact with the field enough to cause minute little disturbances. I need to be able to screen those out. I was going to get in with the oscilloscopes and stuff, and then I thought, duh, you've got, you know, a cheap, huge, giant interactive infrastructure of engineers who are quite happy to sell you little modules to plug all this shit in and, you know, and control it all, right? So I'm going to end up with a control system that'll be run through sound, which is why this is all so amazing that I had such terrible sound today, because I was loading all of these software solutions to isolating sounds and so on, and realized I've got to go hardware basically because of the mechanism I'm trying to make, where I'm going to have some form of an activation process here that works, where I can stand out here outside the field and push buttons and crap and have this stuff work. And then if there's, you know, a permutation of the field, it comes on out and my ears hear it, and also my sound, I'm going to have, you know, recorders and crap. So I'll be able to pick this up and we can quantify it, analyze it, and so on. Anyway, so various different kinds of ways of doing this. And so I'm going to end up with and the amazing part of it is Theremin's reasonably cheap, you know. Yeah, you can spend $10,000 for a 1929 replica. They're over 100 years old. 1929 replica of an RCA Theremin produced in, you know, cherry veneered cabinetry and stuff, but there's no need for that. I've got myself very middle range, well, no, it's probably pretty quality. It's a performance grade instrument because I need that sensitivity. But it's not killer for cost. Neither is any of the little module stuff. The module stuff is very much like the Arduino shields and how you're always plugging in electrical connectors. So it's in the running of the oscilloscopes and so on is reasonably straightforward and so on. Now I need to get all of my other sound issues out of the way and put in a podcast splitter mixer board so that I'll be able to isolate the sounds further from various different pickups around it, and then we'll start getting to work on being able to get at the materials. So all of that, all of the Theremin, all of the modular stuff out here with all the patch cables and crap, all of that, whatever that is, because we don't even know what that is yet, and we don't even know what the mechanism is going to be around those, all of this has to be built in order to just start going through materials. We've got a good selection of materials here. I'm working with some people. David Morgan's going to put me in contact with some material experts. I mean, like people that, you know, advise, like a guy who advises the copper industry on copper, that sort of thing, right? I mean, like serious people. So I'll be able to step through some of the likely candidates, learn what I need to, and go on. We've got a... Oh, also, okay, so now, okay, so I'm an evil fucker. All right, everybody says that. The blue chickens say I'm an evil fucker. And so there's no getting around it. I'm an evil fucker. And I'm going to have this Theremin sitting here. And I live over here on a bluff over the beach. So it occurs to me. And so I got a speaker and a small amp. And what I'm going to do is to set those outside in the spring and the summer and the fall. And go make spooky 1950s sci-fi noise. Blast out over the beach. Because you won't be able to see where it's coming from. So I'm an evil fucker. But in the future, if you hear that there's, you know, dozens of spaceships battling it out in the fog over here in the Pacific Northwest, you'll know who to blame. Okay. Okay. All right, so basically that's where I'm at. This is what I wanted to communicate. The idea of how I got into Boscovich and how it's related to the Tic Tac UFO. And the details are incredible. We can go down into dozens of different aspects of the actual mechanism and how it would need to do this and how Boscovich has already described that in his writing. And it's like he's laying this out for us, guys, to where if we make these breakthroughs in materials, we can start building our own UFOs, and you can build them out of cardboard. It wouldn't matter much because the shield protects you, the force field itself. It just has to simply be rigid enough to allow you to survive in whatever environment you choose to land in. So you wouldn't want to necessarily build a cardboard UFO if you were planning on going to the moon. Right? So anyway, but you can make one out of a bathtub, probably. Okay, so we're going to get Theremin. It'll be here at the end of the month. I'm putting together all of the modular crap now that I'm going to need. I've got some plastics manufacturers that are going to provide me with various different kinds of plastics in various shapes. I've got this friend of mine, Jerry Duran, Duran Interstellar, who's got 3D printers, and he's a machinist. He used to work with Jacques Cousteau, you know, like mechanical engineering kind of guy, right? Software, the whole thing, firmware. So he'll be participating in helping me design and build some of this stuff for our actuators. And then we'll be able to sit out here outside the field, have our coffee, put something in there, turn the field on, tune it to wherever it needs to go, hit the button, nothing happens, collapse it, take the thing out, pitch it into the reject pile, and go on to the next thing. And at some point, we'll get some of these things that will actually interact and give us the response that we want, and then boom, we're off. If we can find one of them that provides one of 3 different kinds of responses, then we can define it as to why that response exists, and we can guess as to what materials will provide the other 2 responses and really narrow it down. And all we need is one of the 3 different kinds of responses in order to be able to get to that point. And so, I'll be right back. Now, I suspect for some of the reasons stated in Boscovich that we'll be dealing with something related to gallium, okay? And I suspect this because I've been looking at LEDs, which are primary light sources. I'm not going to go into light, but Boscovich, this guy who wrote this book, also wrote a book before this called Delumini, the light, okay, or from light, of light. And it's a discussion about what light is. Anyway, because of the primary nature of LEDs and what they're doing to create light directly through the magnetic interaction with the dielectric, and those are dependent on gallium. Gallium's a weird metal because it'll actually melt in my hand. It leaves a stain, and it's not harmful, not toxic at that level, but I don't like the fact that it actually is merging with my body, so I'm not going to demonstrate that here. It's not toxic, like I say, but anyway, so I suspect that we'll end up using gallium in this process, and I suspect we'll probably be ending up with a complex material, probably a sandwich. So for instance, I'm already starting to quantify the nature of the types of aluminum we'll need for shielding if we have to go to physical effect shielding, because we found we can actually polarize magnetism by taking sheets of aluminum, heating them up, because they exist with all aluminum sheets, all aluminum of any kind is covered on the outside by aluminum oxide, okay? Aluminum oxide. And the aluminum oxide melts at about 3,500 degrees, whereas the aluminum inside melts around 1,200 degrees. This means that you can do something really interesting with it. You can, at a small shop level, right? I can go out and I can get my tungsten ionized gas, my TIG welder, and I can hook that up. It's an electrical device, and I can get this thing hot, and I can approach that temperature without reaching it, and the aluminum will not change shape. It'll bend a little bit as we get real close to it. But if I get over the 1,200 degrees by some significant amount, 1,600, 1,800 is about where I try and keep it, about 1,800 degrees, I can get this aluminum bar to essentially be liquid inside the aluminum oxide. Now this is a very touchy period because that bar will sag and melt if you just get over a certain point there, and the aluminum oxide will rapidly become hot, and then it all melts on you and got a big mess. But what I'm attempting to do is to heat up this thing right here, and then I pass a very strong magnetic field one way repeatedly over it, and you get this flaking, this alignment when it cools down, where the aluminum internally here appears to align in kind of like plates, little plates that don't exist when you cut it, or don't exist in its natural sheet shape from Home Depot. But when you cut it with a saw or grind on it, you see that indeed you have been able to alter the internal nature of the aluminum with this really strong magnetic field. That's when I first started getting the sleep impacts from the magnets, was when I was trying to do some of this a while back. That was when I was doing my thing for ray guns. So you can polarize magnetism. Aluminum reacts to magnetism. That's why we can shoot it out of rail guns. You can polarize magnetism with it, and you can also use magnetism to alter the aluminum to make it more polarizing. And so that sheeted aluminum has a real, or that flaked aluminum has a really good polarizing nature. It's not quite, I think it's a 45-degree polarizer, maybe something over 45 but not 90. So you can't just do opposing plates that way in order to get a complete blockage of it. You need to keep increasing them and altering the flow, because it gets real complicated. But we do have that. We know that we can do a physical aluminum shield if we had to protect any human that was inside this stuff. So we are making progress here. Stuff's getting done. Got pure carbon. The pure carbon is going to be used for some of these magnetic experiments. It's really cool. I mean, got the iridium, got rhodium, and a bunch of the other gallium-like or close metals showing up. And so that's all good. That's another reason for the C60, because I'm messing with stuff that is magnetically radiative and electrically radiative. And if you've ever done TIG welding or serious high energy arc welding, you know you get a radiative, oxidative radiation backlash from those. So I'm pumping myself up with the C60 to eliminate the impact of the rads on me, because it's going to get more serious as we go forward on this, right? Once we understand what we're doing, once we've got our three materials, one of those three materials, which may be aluminum in particular ways that we haven't reached yet, will 100% shield us from the effects of what we're dealing with, and then it won't be so dangerous to do this shit anymore. And we don't, I really honestly don't know how dangerous it is, because we're going to be dealing with magnets in ways we've never attempted. Anyway, though, so taking C60 as a anti-radiation effect, I'm obviously doing pretty good. The cancer is not an issue anymore. I'm just trying to clean up a few housekeeping things here before signing off. Sorry about the sound issues. I'll eliminate a lot of that stuff out of the PCs, or out of the server here. And then probably introduce a bunch with the new gear. Okay, so Antarctica. So we're getting results, or getting reports out of Antarctica that there's these high energy particles that are whizzing out of Antarctica, right? Yeah, C60 is worth taking for young people because we don't know where it becomes effective. And also, here's something else. Okay, so let me quickly get rid of all of this, and we'll talk C60 here for a second, and then I'll go in and do other stuff. Okay, so the idea with the C60 is I've frozen myself in a sense that that's what I'm attempting to do, is to prevent further age deterioration, right? Well, if I'd been 40 when I'd done it, I would have looked a lot better. Okay, so if you're young, you're going to capture more of your potential in the future. So that's the point of taking the C60 as a young person, right? Okay, so here's the Earth, here's the Sun. The Sun is shrinking its corona, so it's coming down as part of us going into the Ice Age. That means that more high energy particles come whizzing around the Sun here, and some of these buggers are going to come on in and they're going to hit us. Only some of them might go through Earth, but we have a plasma core down here, and the plasma is hugely magnetic. It's what creates our magnetic field. It's going to draw these cosmic rays and other things to it. Okay, so it's getting more energy as the corona of the Sun shrinks and more stuff comes around, because the corona of the Sun is an indicator of its magnetic activity, and if it were way out there, it's magnetically going to suck these cosmic rays and stuff up. So we're going to get more. What happens? Well, our plasma gets them, and it can't get rid of them. Okay, this would be a cosmic ray coming into the plasma. Goes right through us, right through your car, right through your house, right through the Earth, and then it hits the plasma, but it doesn't come out the other side of the planet because the plasma traps it in the big magnetic bubble down there. And over time, the plasma must necessarily increase its size. And at some point, it runs into the pressure of the planet around here. So here's our plasma, and here's the Earth in general around it. As the plasma tries to increase, it runs into matter, what we think of as, the molten core and all of that kind of stuff, right? the magma and the mantle, okay? And as that plasma tries to increase, fundamentally what happens is a compression at an atomic level, if you will, and we get matter created. And so the plasma creates more matter, and it shoving it out from the inside of the planet. So what happens is the planet breaks loose up here a little bit, little holes, which we've seen for years, the sinkholes appearing, this kind of thing, are an indication of all of these big rocks that are really forming up our planet, separating slightly. When they separate down here at the South Pole, here's Antarctica, when these big rocks separate, we get this other effect. That other effect is, oh look, it's less pressure here than there is here at the equator. Here's the South Pole, here's the North Pole, and here's the equator. There's less pressure on the plasma at the South Pole, so it's less likely that any energetic particle trying to get out is going to be converted to matter. And so we see these high energy particles leaking out of the Antarctic pole. Why do we see this? Because we've got high energy particles down, particle detectors down there looking for particles that were coming in from space. And we discovered that there's a bunch of the buggers coming out of the planet. It was an accident. I don't think they were intended to see if they were coming there. They were actually, the way they talk about it was specifically looking for space particles inbound. And here they discover these particles coming out of the planet. Well, they're coming out because that's a leaky area of the planet, so to speak. And I bet you, if we happen to have a detector at the North Pole, you would find that that area is also leaky. But there's a slight difference between the nature of magnetism at the North Pole and the South Pole. Beyond its attraction repulsion issue, it has to do with the ability of it to, or the amount of compression versus rarefaction. And so there will be a difference in high energy particles from the North and the South Pole. And at the moment, it appears that our South Pole, which is actually our North magnetic pole, not our North geographic pole, but it is actually our North magnetic pole, is leakier. And so thus we're able to get a lot more high energy particles out of there. But this is also a sign of the next phase of the expansion. And the next phase of that expansion is what puts us in through the next little tip off into the Ice Age. So we'll see all kinds of effects here over the next few years that will be piggybacking off of this effect down here. I got to get moving. This has been a long damn time. Sorry about the sound issues. I think maybe we've got at least one part of it done in terms of stripping out a bunch of shit. So I'll be seeing you. What else? There was, a shout out to Doyle on Twitter. Sorry, guy, I wasn't being pissy. It was just early in the morning. All right. I think that's it. Got to do some more experimentation when we got the thermins in, and I'll make some spooky noises on a video for you and show you how it works. Thanks, guy. Talk to you later.